So welcome to today's video. Today's question is fruit into baskets. So you are given a farm that is a single row of fruit trees arranged from left to right. The trees are represented by an integer array fruits, where fruits of I is a type of fruit that, the ith tree produces. I mean, suppose there is an array of trees. Each tree has a type like apple, mango. So this fruits I is telling it is of type 1, type 2, type 3. Like see, this array is 1 2 1, so means this is of same type, these trees, and this is of other type. Second, you want to collect as much fruit as possible. However, the owner has some strict rule that you must follow. We have to collect as much fruit as possible, maximum fruits. You only have 2 baskets. This is one condition, that we have only 2 baskets. Each basket can hold a single type of fruit. So in one basket we can hold one, and another basket we hold 2. There is no limit on the amount of each basket. Each basket can hold any number of the same type of fruit. Starting from any tree of your choice, you must pick exactly one fruit from every tree. We can start from any tree, but it should be contiguous. We cannot skip. See, you must pick exactly one fruit from it. We cannot skip. We have to pick. If we start from one tree, now the trees ahead, we have to pick at least exactly one fruit from every tree. Not more than one fruit, exactly one. We cannot skip also, including the start tree. While moving left to right, the picked fruit must fit in one of your basket, and we have to fit in the basket. Suppose we have put 1 into one basket, 2 into another basket, now 1 to first basket, because same fruit in the same basket, same type of fruit in the same basket. Once you reach a tree with a fruit that cannot fit in the basket, you must stop. Suppose there is a third type of fruit. It cannot fit into the 2 baskets. So you want to give a sub array or array of fruits with a maximum number of fruits. Means we have to find the longest sub array which can hold 2 types of fruit, which is having 2 type of fruit, and so it will return the maximum number of fruits you can pick. So it is a type of question to find longest sub array with at most 2 type of fruits. So we can use a brute force approach. What is the brute force? Let's see. Suppose this is an array 1 2 3 2 2. So basket 1, basket 2. What is brute force? First of all, what is sub array? Like this, sub array starting from 1 is 1 1 2 1 2 3. But see, this sub array is consisting of 3 types of fruit. 3 types of fruit. But we want at most 2 types. At most 2 types of fruit, because there are 2 baskets only. So we have to stop, and we will update our max length to 2. Okay, stops. Now again, start your tree. Choose your first tree. Let's suppose 2. Now sub arrays from this 2 3, then 2 3 2, then 2 3 2 2. Now max length updates here to 3, and here to 4. Now you will make such more sub arrays, but you will get maximum 4 only. So this way the knife solution we will approach towards. Let's write the code. I hope you understood. First of all, we make a max length variable. We'll store the max length here, maximum number of fruits that you can pick in this variable. And suppose we are starting with first tree. Now we have to make baskets. How we will calculate that the sub array is containing only two types of tree, not more than two, at most two types of tree only. We can make a set data structure. In this we can put our trees, in this we can put our fruits. So we will start j equals from I, because number of sub-arrays we have to calculate. We have seen in our previous videos how to calculate the number of sub-arrays every time. Different types of sub-arrays means how to generate them using the two for loops. Now suppose we got our first tree, we have to put in the set. Let's put in the set. st dot insert, let's put it on the set fruits I. Suppose you put this into the set. If st dot size is greater than 2, then we have to break, else we will increase our max length. We'll update our max length to r minus l plus 1. Why? Suppose your I is here and j is here, so what is this? 1 minus 0 plus 1, because 2, there are two fruits, that's why. And suppose there are more than 3 fruits in our set, in our basket, 3 types of fruit, then we have to stop there, because we can hold only 2 type of fruits. And in max length we will have the maximum. I think this is the only solution. Return max length and check. Obviously it will show time limit exceeded, because constraint is 10 to the power 5 and our time complexity is C. One for loop n into t is big of n into log 3. Log 3 is why? Because in set to make option like insert or dot size, we have time log 3, and every time it is happening, so inside the two for loop, so it is multiplied, and space is very less, and this is approximately equal to big of 1, and this is approximately equals to big of n square. Space complexity is log 3 only, because set is of maximum 3 size, because after that we are stopping and relationizing the set. Let's run this code. st dot size, not s dot size. Actually this is fruits dot size, fruits vector. Now let's run again. Max line is r minus j minus I. Variable naming is incorrect by me. Now what is filling? Expected 4, 5, 1 is extra coming. This is very wrong. Why it is happening? Let me see. Insert the fruits. We have to insert the fruits if we are unable to find. Okay. I think we have to only insert the fruits. This time. Wait. By mistake we have written fruits of I. The loop is about j and we have written I, because we are moving in an array like this from j using j pointer. Let's now run this code again and we will see the right answer, and one test case is failing again. What the test case is? When actually we have to insert here only, I think. Let's see. Yeah, we insert the first in our set, then check our size. If size is less than equal to 2, then we will update the max length. Then again same process happen. We will update the fruit set. And this also time exceeded. See, but maximum test cases are passed. Now, what is optimal solution of this? We will see now. Okay, so let's move on to the optimal solution or better solution, because optimal we will be big of n, but this is better. So we have find that we are using subarrays, and in subarrays we can use two pointer approach. So let's take an example of this. 1 2 3 2 3 2 2. Now we will use a left pointer and a right pointer. Now what we have to do? Let's take a map. Before we have taken a set, now let's take a map. Let's make it like this, and we can make like this. What it contains? It contains the type and type comma frequency of that type of that type of how many count of fruits of that particular type. So let's start the loop. So first we will see 1. We'll put in the map. Firstly we'll put in the map with the count 1. Now when we saw that our max length increases because our number of fruits are less than equal to the types of fruit less than equal to k, which is 2 here. So we can update the max length. We can update the max length to 1. Now we will increase the right pointer. Now we are seeing 1 and 2. This is okay. This is less than equal to k. 2 types of fruits are only there. So we will firstly put the 2 in our map, that we have covered this type of fruit and it is a count 1, and then we will update the length, which is 2, 1 and 2, and actually that is r minus l plus 1. If you are confusing, how? Suppose r is here, this is index 1, this is index 0, so 1 minus 0 plus 1 equals to 2. Okay, let's move again. Now we have got in map 3, 1. Now it will check how many types of fruits are there. Now there are three types of fruits, because map size, we are checking how many types of fruits in our basket by this, using this in our window, using this map dot size, which is 3 currently. Now we have to decrease this type by trimming from the left. In sliding view we trim from left. How much we have to trim? Let's see. We are seeing this. Our left pointer is on 1. So we move the left pointer. Let's trim. Let's make it 0. And when it becomes 0, we can remove it. We can remove this from the map. Let's remove it. Okay. Now it is not in the map. When it is not in the map, it is a valid window, and we can update our max length, but it is 2 only. There are 2 types of fruit. Total fruits are 2 only. So we will not update. It is same. But our window L pointer moves and map size becomes 2. This is the approach. Now again right pointer will be moved. Now it will update the map. It has frequency now 2 type. The type 2 has frequency 2. And now we'll see the max length. Window size is 3. And it is valid because types are 2 only. So maximum updates to 3. Now again the right pointer moves. Now this time R updates to maps type 2 updates to 3, and max length updates to 4. Again, when R moves, while loops break. So this is an example. Suppose there would be one between here. So let's try it again fastly. First of all, R came, first of all, map size equals to 0, and this is also 0 initially, and we do not have this, we do not have this, we do not have this, we do not have this. We start with R, we insert in map 1, 0, 1, 1, move our update our max length because it is less than, type is less than equal to, number of type is less than equal to 2, at most 2 we want. Then we will update the right pointer, increase it plus plus by doing plus plus. Now map size becomes, now we will insert in map 1 again, but 1 is already there, so we will update the frequency only. Okay, now window size is 2, map size is 1 only, we have not updated the map size before. Window size 2, number of foots actually is 2. Now again R pointer updates, map size becomes 2. Why? Because there is one more type in the map, which is 2. Now again we will check, window size becomes 3. See, now again R increases, and this time it inserts 3, 1 in the map, but map size becomes 3, means these are the types, 3 types of roots, which is invalid, so we will have to trim it down from the left. Let's trim it down. First of all, this will decrease, so map size becomes 3 only, still invalid. Again, now it becomes valid. When it becomes 0, we'll erase it. Now it becomes valid because now their map size is 2 only. When map size is 2, max length is how much? 2 only, so it will not update. Now increase the R pointer, this we will update the map size becomes 2 only, and max length becomes 3 only. Now again update the R pointer, update the map, number of window size becomes 4, so we will update the max length. This is the answer. When again it will run, it will go out of bound, and while loop break, and we have got the answer, max length equals to 4. Now let's write the code. Initially max length equals to 0, and initially left pointer equals to 0, initially right pointer equals to 0, and initially map int, int is map. Put a while loop. What is the condition of while loop? Fruits dot size. R will run throughout the loop till n elements from 0 to n minus 1. So 1 big of n is here. We have got 1 big of n here. Okay. Now firstly, it will insert in the map. Map of fruits, R, fruits of R is plus plus. Insert in the map. Now it will check, while it will check is map dot size greater than 2. If it is greater than 2, we have to trim it from the left. So for trimming from the left, we will do this. If map dot size minus, first we will do this, and actually we will not do this, we will do fruits of I of that index. Where is our L? L is here, suppose. So map of L is, we have to decrement. We have decremented. L also becomes plus plus. Now suppose if map of fruits of L before this only. After decrementing, it becomes 0. Suppose it becomes 0. Then what we have to do? We have to erase it, because otherwise it will be -1, or it will be 0, stored as 0, 1 comma 0. We do not want it. We want to erase it, so that map size decreases. Map dot erase roots of L. See, this was the important point. Now what we have to do? Now we will see, we have checked one condition, that is fruit types of fruits are greater than 2. Now we have made it less than 2. Now successfully we will check first, again we will check if map dot size is less than or equal to 2. Then we will update the max len to maps of max len comma r minus L plus 1. See, now after each step we have to update the right pointer. Now we can return max len. I think it should work if I will not make any mistake. Let's see, it is running. Let's see time complexity of this while loop. So it will maximum one time run. So maximum big of n. I will show the example when it will run big of n time. And map operations will take log 1 or log 3, because maximum size of map is 3, because we are erasing when it becomes greater than 2. Okay, it is approximately big of 1 only, big of 1. Now space complexity is also big of log 3 of map, and time complexity is big of n plus n into log 3, which is approximately equals to big of 1 only. Let's write it equal to big of 2n. When it becomes big of 2n, suppose in this example 2 2 2 2 3 4, when our L is here and R reaches here, so it becomes 3, types becomes 3, which is not equals to 2, okay, less than equal to 2k. So we have to move left pointer till when 1 2 3 4 5 n minus 1 times, approximately n. This is the case when we see our while loop takes big of n. So overall it takes big of n time in worst case. That's why we add and say it's 2n. So this was the solution. I think you understand. Now we will move to optimal solution. Now we are moving to optimal solution. Yesterday we also saw in our question that in maximum consecutive ones, that how to optimize from 2n to n by reducing while loop to only if and limiting our max length and updating only when it is less than equal to k. So we will see how we'll do a dry run of it. Suppose I have taken this pen and just close it. Close. Now we will take this pen. See, array was suppose this is an array. We have left pointer, R pointer. We have a map. Okay. Now see. First it will initialize it with 1 and 1. Now what is R value? R will update here. And also max length will also update it to 1. Now see, 1 is inside the map, but it is of the same type, so it will be updated again. So we will update this to 2. Again, R moves. It is also valid because only one map size is 1, which is less than equal to k. Again, it will increase to 3. Now R moves again. Now map size increases to 2, and here we got 2, 1. Now when R comes here, it sees map size equals to, it updates the map, it inserts in the map 3, 1. Okay. Now see. Now L. What about L? The window is this, and it contains 3 fruits, which is invalid. So what will we do? Because max length till here become A1, 2, 3, 4. I did not show you, but it becomes this. And when it comes to 3, window size is 5, but because of 3 size of map, it fails the condition of less than equal to 2. So we do not update it. We update it only when map size is 2. So when it fails, we'll move the L by 1. Now again see the window. Is it valid? Again it contains 3 types. So we will just move R. We will just move R by 1. Now when you moved R, see, it increases to 2. Okay. Now again see, it is invalid. Map size is 3. So we'll again move L. You're seeing in this window, L minus R is just 4. But we will not update because it is not, map size is not less than equal to 2. Now again we will move R because it is invalid. See, now you see this window is also invalid. We will update, also update the 2. Map size is 2. Just update R and also update this 5. It is also valid. That's why it is updated. No, answer is 5. Answer is this window. Okay, got it. So let's move to our code. How code will be written of this. Only one change here. If now it will be run. Now this time obviously will not be taken. And see, it will run 100%. Then I will submit because internet is slow. Actually it is better than all, but I don't know why it is not submitting because of internet speed. It is better, optimal. It is not sum, it's mistake. Okay, so hope you enjoyed the video.